Hi ladies, this is lesson 4.9. It's graph and solve quadratic inequalities. So we've been working with quadratic equations, and we have worked with linear inequalities, but we haven't done quadratic inequalities. But the concept is the same. You're going to graph the quadratic, and then you're going to pick a value, a coordinate that is not on the graph, and see if it's a solution. So by graphing a quadratic, you're still going to have two half planes, just like when you graphed an absolute value. So we're just going to define quadratic inequalities in two variables. And with the quadratic inequality with two variables, you have an x and a y. And with a quadratic inequality in one variable, you just have an x, and the inequality is not equal to 0. It's either greater than or less than 0. So quadratic inequality in two variables is y is less than ax squared plus bx plus c, or y is greater than ax squared plus bx plus c, or it could be y is less than or equal to ax squared plus bx plus c, or it could be y is greater than or equal to ax squared plus bx plus c. And then our quadratic inequality with one variable, ax squared plus bx plus c, is less than 0. Ax squared plus bx plus c is less than or equal to 0, or greater than 0 or greater than or equal to 0. So there are inequalities, and with two variables you have an x and a y. And with one variable, you just have an x, and the y is set to 0. So that's where you would solve for the zeros, or find the zeros, is in an inequality with one variable. So when you're graphing your inequality in two variables, you need to follow these 3 steps. So the first step is to make a parabola, graph a parabola, first of all, is to graph it, but make it with a dashed line, or make it dashed. For inequalities and solid, for inequalities that are less than or equal to or greater than or equal to. Then you should test a point that is inside the parabola to determine whether or not it's a solution for the inequality. And then you should shade the region inside if it is a solution. So inside if it is a solution, and outside if it is not a solution. So if in the area where you checked whether or not it's a solution, if that is a solution, shade that area of the coordinate plane, and if it's not, shade the other area. So first we have to remember how to graph our inequalities. So we're going to do this example 1, we'll do it together, and then you can do the second one on your own. So the first one, graph the quadratic inequality, y is less than or equal to, so this right away tells us it's going to be a solid line, negative x squared plus 2x plus 3. So the very first thing we want to do is find the axes of symmetry. So that's, if you remember, negative b over 2a. So in this case, it's negative 2 over 2 times negative 1, which is negative 2 over negative 2, which is 1. So that's our x-coordinate of the vertex. To find our y-coordinate of the vertex, we just have to substitute in 1 for x. So our y-coordinate is negative x squared plus 2x plus 3. So that's negative 1 plus 2 plus 3, which is 4. So that gives us our vertex. So let's graph that first. There's our vertex. And then we have to choose 2 points on both sides of the vertex. So I'm going to choose 0 and negative 1 as my x values. So if x is 0, then I have negative 0 squared plus 2 times 0 plus 3. So my point is 0, 3. So I'm going to go ahead and plot that. And then if I choose negative 1, substituted negative 1 for x into my quadratic equation, and I get negative 1 minus 2, which is negative 3, plus 3, which is 0. So my point is negative 1, 0. Now remember, you have to plot the symmetry points. So go ahead and do that, and then you can sketch in your parabola using a solid line. All right, so now since it's an inequality, you have to choose a point. I'm going to choose this point, 0, 0, because I think it's easy to work with. It's not on my line, it's inside my parabola. So choose a point inside your parabola and determine whether or not this is a solution. So is 0 less than or equal to negative 0 squared, which is 0, plus 2 times 0, which is 0, plus 3. So is 0 less than or equal to 3? Yes, it is. And since that is a solution, that is the area that I'm going to shape. All right, so please try this next one on your own. Follow the same steps that are given above. First, you want to graph your parabola and use a dashed line because this one is an inequality that says strictly y is greater than. And then find your vertex, and then find a couple other points, and then pick a point inside your parabola to determine whether or not it's a solution. So please pause the video while you work, and you can unpause for the solution. All right, so far here's what my parabola looks like. This is before I actually pick a value for x and y, before I actually pick something on my coordinate plane to determine whether or not it's a solution. So first of all, check your parabola to make sure that that's correct. And then you can go to the next step and test a solution. So I chose the point 0, 0 because it's inside my parabola. And it is a solution. 0 is greater than negative 2. And so that's the area of the graph that I'm going to shade it. So the next step in graphing inequalities is graph a system of quadratic inequalities. And again, we've graphed a system of linear inequalities, but we haven't done it with quadratics yet. But it's the same idea. You want to graph one quadratic and find the solution for the inequality. Then graph the second quadratic and find the solution for the inequality. And the area of the graph where you overlap is the solution for the system. So we'll do this first one together. So in the first inequality, you know that it opens down. And you're going to use a solid line. So first, let's find the axes of symmetry. Negative b over 2a. In this case, b is 0. So our axis of symmetry is 0. And then to find the y-coordinate of the vertex, you substitute in 0 for your x value. So you get negative 0 squared, which is 0 plus 4. So that tells us that our vertex is 0, 4. So we're going to start with that, and you can go ahead and graph it. Pay attention to the scale on your graphs. Then we can find two other points. So I'm going to choose points that are to the right. So I can choose, let's choose 1 and 2. So if x is 1, our y is negative 1 squared plus 4. So that's negative 1 plus 4, that's 3. So my point is 1, 3. And if I choose 2, it's negative 2 squared plus 4, which is negative 4 plus 4, which is 0. So now I can go ahead and plot those points. So 1, 3 is right here, and 2, 0 is right here, and then plot the symmetry points. And using a solid line, and yes, this opens down, that's good. That's what I expected. All right, now I'm going to test a solution. So I'm going to test 0, 0, because it's inside my parabola, it's not on my line. And when I test 0, 0, I plug in 0 for y. So is 0 less than or equal to negative 0 squared, which is 0 plus 4? So is 0 less than or equal to 4? Yes, it is. So I'm going to shade that region of my graph. And you can use highlighter or pens or whatever colored pencils you want. It is easier if you use something other than just a regular lead pencil, so use some kind of color. Okay, so that's my first one. And my second one, I'm going to use a dotted line. And I know that it opens up. So I'm going to start the same way. I'm going to first find my vertex. So I have to find my axis of symmetry first. And that's negative b, which b is negative 2. So negative b over 2a, which is 1. And then I'm going to substitute 1 in for my x value. So that's 1 squared minus 2 times 1 minus 3. So that's 1 minus 2 minus 3, which is negative 4. So my vertex for this one is 1, negative 4. So I can go ahead and plot that, 1, negative 4. And then I have to find a couple other coordinates. So this time I'm going to go to the left. So So I'm going to choose if x is 0 or if x is -2. So it doesn't matter which points you pick, but go on the same side of the vertex. So if x is 0, then my y is 0 squared, which is 0, minus 2, 0, which is 0, minus 3. So 0, -3 is 1 point. And then if x is -2, that's -2 squared, which is 4, minus 2 times -2. So plus 4 minus 3 is 5. So my second point is -2, 5. And so I can go ahead and plot both of those points. So 0, -3, and the symmetry point. And -2, 5. And the symmetry point. So let's say to go over 2 units from here. Which is there. All right, and I'm going to need a dashed line. And then my last step is to test a point. So I'm going to test this point again, because it's inside my parabola, it's not on my line. You won't always be able to test 0, 0, but so far it's worked. Okay, so if y is 0, is that less than 0 squared, which is 0, minus 2 times 0, which is 0, is 0 less than -3? And in this case, no, it's not. So for this parabola, I have to shape outside of the parabola. And then my solution is where that overlaps. So now you can see from like my green area, this is my solution. So the part that I just went over again in red pen, very clearly marked as the solution. Okay, where any point would satisfy both inequalities. Alright, so this next one I want you to do on your own. I think you have a graph, an actual graph on your note sheet, which I'll have to put one up here. But do this one on your own, so please pause the video while you work, and you can unpause for the solution. But remember, you have to graph both parabolas, both quadratic inequalities, test a solution for both of them, and then your solution for the system is where both of those overlap. Actually, if you look on your note sheets, this is the problem that you should be using, so you should actually pause here. If you recognize the last one, that's the one we just did. It got doubled up on these slides. So pause now and graph these two inequalities. All right, here is the first inequality. We know it opens down. We're going to use a dashed line. Find the vertex, that is 0, 3. Find two other points and then graph their symmetry points, and then test a point that's inside the parabola to see whether or not it's a solution. So again, I tested 0, 0, which yes, it was solution, so that is the area that I shaded. All right, so the second one was a little bit trickier because you got a fraction for the line of symmetry. So for sure, anytime I get a fraction, I like to draw that line of symmetry in because it helps with the graphing. So then you get your vertex of -3/4 and -25/8. When you're graphing, it'll help you to kind of give you an idea of where that is. So either put it as a mixed number or you can put it as a decimal. And with these long decimals like this, you're not going to get it exactly, so just graph about where it would go on the graph. So you can see my vertex in green. And then pick another couple points. And then graphing the symmetry points is a little tricky when you have fractions. So that's where the line of symmetry comes in handy. So just pay careful attention on where your line of symmetry is and how far you're moving from each side. So for example, here and here, they're both 3/4 of a unit away from the vertex. And then my last point, here was my x value of my last point, and here was my x value of my last point, and so they are both now 1 unit away from the last point. Okay, so just pay careful attention when you're graphing symmetry points like this. And then I tested the point 0, 0, and yes, it was a solution. So now I'm going to use my highlighter to shade in that area of my graph. And my solution for the system is that green region that satisfies both of those inequalities. Okay, now the next step for this lesson is to solve a quadratic inequality by graphing. So to solve a quadratic inequality by graphing, you're going to use the quadratic formula. So again, our quadratic formula solves for our x, solves for our zeros, and it's -b plus or minus the square root of b squared minus 4ac all over 2a. So first we want to get this into standard form, which it is, it's set to 0. And now we want to identify our a, b, and c. So a is -3, b is -5, and c is 3. And then we can use that to substitute those values into our formula. So -b plus or minus b squared minus 4ac all over 2a. So then you can simplify. You have 5 plus or minus the square root of 25. 4 times -3 is -12. -12 times 3 is -36. So minus -36 is plus 36 all over -6. So again, if we simplify, we're left with -5/6 plus or minus the square root of 61 over 6. Now you don't need to leave that -6 there because you already have the plus or minus. So it's square root of 61 over 6. And now we're going to think about what this graph looks like. So we know it's a quadratic, so we're going to graph a parabola. And we know that it's going to go down. So we don't have to completely graph the whole thing. We want to plot this point And so it's going to help us to kind of figure out what that actually is. So in your calculator, go ahead and -5, 6, either plus the square root of 61/6 or minus the square root. So here, if we go back here, we're going to say x approximately equals 0.47, and x approximately equals -5.6 minus, which is -2.14. So we can put these on our graph about where they'll lie. So x is approximately 0.47, so it'll be just under half. And then x is approximately -2.14. And we know that this parabola goes down. So we don't have to do the whole thing, but it'll look something like this. So to solve this inequality, we want to know, where does this graph go below the x-axis? So we're looking for, this really is our y. So when is y less than or equal to 0? So our outputs for our x's are less than or equal to 0, so they're on or below the axes when x is less than or equal to approximately -2.14, or -5/6 minus the square root of 61/6. So this is one part of our solution, and here's the other part of our solution. And although the graph may not be perfect, you don't have to graph the whole quadratic. So the graph lies on or below the x-axis when x is less than, and actually we should even put our decimal in our answer because that's just what we use to kind of get an idea of where we graph this. So when x is less than or equal to -5/6 minus 61/6, or when x is greater than or equal to -5/6 plus the square root of 61/6. So again, just to kind of summarize, we want to know where the graph is. So here, the graph of the quadratic lies on or below the x-axis when this is true or this is true. So those are our solutions for the inequalities. So try this next one on your own. And here you're looking for the graph when it is on or above. So when is the graph on or above the x-axis? you work, and then you can unpause for the solution. So remember, you don't have to graph the whole function, but you do have to set the inequality equal to 0, and then find the zeros, and then sketch in your parabola. All right, so I plugged in my values for the quadratic formula, and I got my two zeros, either x is 1 or x is -5/2. And so I plot those, and I know that my graph opens up. So I don't have to graph it perfectly, I just have to know that it opens up. And then the question is, when is the graph on or above the x-axis? And the reason I'm asking that is because it's greater than or equal to. So when is 2x squared plus 3x minus 5 greater than or equal to 0? And that is true here or here. So therefore, my x values are going to be to the left of -5/2 and to the right of 1. So x has to be less than or equal to -5/2, or x has to be greater than or equal to 1. Right, so I know this video is getting kind of long, but it's a 2-day lesson in class, so it's going to be a little bit longer. But the next part, this is our last type of quadratic inequality, and we can do this algebraically. And so we're going to show it on our number line here, but we're going to follow the same steps. But here we're going to use factoring. So if we can solve it algebraically, we will be able to factor. So we're going to write it in standard form. So here our first step is to set it greater than or equal to 0. So we've got x squared plus x minus 12 is greater than or equal to 0. And then let's factor this. So when you factor, you're looking for factors of x squared and factors of -12 that add together to get 1. And these are going to be your critical x values. So x is just 1 and 1. Those are the only factors of x squared, 1x and 1x. But -12, we're looking for a difference of 1, and we want that 1 to be positive. So I'm going to do 4 and -3. So 1 times 1 is 1. 4 times -3 is -12. And then if I add them together, 4 times 1 is 4. 1 times -3 is -3. If I add those together, I get positive 1. That's what I want. All three of those are what I want. So when I actually write it out into my factor, I've got x plus 4 times x plus 3, or x minus 3, is greater than or equal to 0. So I need to solve for my x values first. So either x plus 4 equals 0, or x minus 3 equals 0. So if x plus 4 equals 0, then x equals -4. So that's one critical x value. And if x minus 3 equals 0, then x equals 3. So these are my critical x values. That means they're important. So those are the ones that are going to go on our graph. Now, the graph says greater than or equal to, so these points are included. So let's go ahead and graph these. So on our number line, 0, 1, 2, 3, 4, -1, -2. We'll go to -5. Okay, so here's one x value. Here's another x value. Now to solve algebraically, I want to pick a number in each of these sections. So So here's a section of the number line. So section 1, section 2, section 3. So those two critical x values divide your number line into 3 sections. So I'm going to pick any one number in each section to see whether or not it's a solution. So let's pick -5. Plug in -5 for x. So we get -5 squared minus 5 minus 12. Is that greater than or equal to 0? Well, and actually, you know what? I usually plug it into the original equation. So -5 squared minus 5, is that greater than or equal to 12? Well, 25 minus 5 is 20. 20 is greater than or equal to 12. Yes. So this is the solution. What about 0? Is 0 squared plus 0, is that greater than or equal to 12? No, it's not. So this is not a solution. And then the third one, we'll do 4. So is 4 squared plus 4 greater than or equal to 12? So that's 16 plus 4, that's 20. 20 is greater than or equal to 12. Yes. So here's our other part of the solution. So our solution here is x is less than or equal to -4, or x is greater than or equal to 3. So since you have an inequality, you can't just say x equals 3, x equals -4. Is it greater than or is it less than? Right, so do the same thing, solve algebraically, pause the video while you work, and you can unpause for the solution. Just a quick reminder is that if you divide by a negative number, don't forget to flip your inequality sign. Right, so here's the solution. So if you first factor, you get 2x minus 4 times -x plus 4 is less than or equal to 0. And then when you solve for x, you get x equals 2 or x equals 4. Those are your critical x values that you should plot on the number line. And then those 2 critical x values divide your line into 3 segments. And so you want to test a number in each of those segments to see whether or not it's a solution. If it is a solution, that segment gets shaded. If it's not a solution, then that segment does not get shaded. So in this case, you end up with x is less than or equal to 2, and x is greater than or equal to 4, or x is greater than or equal to 4. All right, so please jot down any questions that you have throughout this lesson, and we can discuss them in class next time I see you. Thanks.